Welcome guys. Today we are going to see how we can derive measure formulas to find the area of a triangle. So I already have my triangle drawn out here. Let's call this side A, call this side B, and call this side C. Now, the first formula we can use is half base times height. Where if you have this type of triangle, the height is just basically if you drop a perpendicular line from the top to the bottom such that it divides B into two equal parts. That will be the height for this triangle. So if you use half this height and this breadth, you're going to find the area of the triangle. Now, another formula we can use is this. What if we have an included angle? Let's call this angle theta between A and B. Which formula can we use? Well, notice that when I dropped the perpendicular line, I divided this triangle into exactly two equal parts, right? So if I bring it out this way, this is what it's going to look like. Now our formula have not changed. We still want to use half base times height, just that we don't know the height in this case. Remember, in this type of triangle now we are given A, we are given B, and then we are given this included angle. Now these are the three things given. In the first case, you'll be given the base, you'll be given the height. You just use half base times height. What if in a case where you're given this side length and this side length with an included angle? Now, how do you find the area? We also know that the area is half base times height, but the case now is we don't know the height. So if I replicate this triangle, it's going to look like this. This cannot be B, right? It has to be, okay, let's call this other side X. Then this has to be B minus X. But we're not even going to use it because we're going to try to define edge in terms of A and not B minus X. So everything now gets complicated. Now, this edge, because of course this is a right angle triangle, remember it was a perpendicular line we dropped, so it's going to intersect the base at 90 degrees. So this is a right angle triangle, so we can use our trig ratios SOHCAHTOA to find the height. Now this height is, you see that it is opposite the angle, the included angle, so we have the opposite side, and A will be the hypotenuse side because it's facing that right angle. So we can use right, because that's opposite and hypotenuse. So it is true to say that sine of that angle theta is the opposite edge over the hypotenuse. So if you make it a sort of formula, we have the hypotenuse is going to be equal to A sine theta. Now we have a relation for the height. So we're saying that wherever we see the height, we can replace with A sine theta. So coming back to our equation, which is this, we can say that the formula will be half base times height, but the height is given by A sine theta. Just to rearrange a little between the B and A, A before B, so it doesn't really matter, but just to do that, we have AB sine theta. So this is another formula we can use. So this is the first formula given the base and the height. Now given two side lengths and an included angle, we can use half AB sine theta. We can do that. Now, what of another scenario where we are not given an included angle, not given the height, but we are given, I'll use another highlighter there. We are given the side A, now it's red in color, given the side B, and then given the side C. So we want to find the area of a triangle given the three sides of the triangle. Now we're going to subscribe to a formula we call the Heron's formula. We're going to use the Heron's formula now. This Heron's formula says that the area of a triangle can be given by the square root of S into S minus A, S minus B, which are basically the side lengths, S minus C. But this S itself is not an imaginary number. S is calculated by adding the three sides of the triangle and divide by 2. So this is the Heron's formula. Do this every time you get the area of the triangle. So that's what we can do. So basically these are the three areas we can use to find the area, or rather these are the three formulas we can use to find the area of any given triangle: half base times height, half AB sine theta, and then the Heron's formula. Except maybe some special cases which we'll just consider one of them. Let's say we have a special triangle, an equilateral triangle, for instance. Now let's use an equilateral triangle. Remember, an equilateral triangle is one where all the sides are equal. So if this is A, this will also be A, this will also be A, and all the angles are equal to 60 degrees. So this is what an equilateral triangle is. So what will be the area? Nothing has changed, right? We can still use half AB sine theta because we don't know the height, so we can use this formula. But notice what's going to happen now. Notice that A is equal to B, so this becomes A times sine theta. Now this becomes half A squared sine theta. Now theta is not imaginary, we really know what theta is. Theta is sine 60 degrees. So what do we have there? We have half A squared is just A squared over 2, and sine 60 is literally square root 3 over 2. So if you multiply this finally, we see we have root 3, because it's not a perfect square, times A squared all over 2 times 2 in the denominator, there is 4. So given an equilateral triangle, you can use this formula to find the area of that triangle. I think it's very, very satisfying and better to understand where these formulas are coming from, and you have a better feel than just cramming it and solving. Having the conceptual idea is really better than just knowing the formula. Now, to verify this formula now, what if we use the Heron's formula instead? Are we still going to arrive at this? Well, let's try it. Remember, this is the Heron's formula. I'm just going to highlight it again, that this is the Heron's formula, and we said that it works for any triangles provided I know the side lengths of the 3 sides. So remember, in an equilateral triangle, A equal to B equal to C. So our S for an equilateral triangle will literally be A plus A plus A over 2. So we're going to have 3A over 2. And then for the area, you see that this is just going to be S into S minus A, another S minus A, another S minus A. Wow. So that's going to be the square root of S into S minus A raised to power 3, right? S minus A times S minus A times S minus A, S raised to power 3, S minus A raised to power 3. So when we plug that in the equation, we're going to have this becomes the square root of S is 3A over 2 times S again is 3A over 2 minus A raised to power 3. So let's see where we are heading to. So our area is going to be the square root of 3A over 2. Now I need to simplify these brackets. I'll use equivalent fractions. A, I can rewrite to be 2A over 2 raised to power 3. So I have a common denominator I can easily subtract. So A would be the square root of 3A over 2 multiplied by, now 3A minus 2A is just A over 2. So that simplifies to be A over 2. Now, I think I'll just continue under here. The area now becomes, that would be the square root, just tired of writing square roots. Square root of 3A over 2 multiplied by A raised to power 3, that's A cubed, 2 raised to power 3, that's 8. So that's the square root of, again I'm writing it, 3A times A cubed will be 3A raised to power 4 over 2 times 8 is 16. Well, we can use the rules of surd. If you have a root sign, you can separate the numerator. So we can have 3A raised to power 4, square root of that, and then separate square root of 16. Good. Also, since 3 is multiplying A raised to power 4, we can also separate it. So we can have square root of 3 times square root of A raised to power 4. Why I'm doing this because I have seen that 3 is not a perfect square, so I don't want to get nonsense as an answer. Square root of 16 is 4 already, so we are done with that. Now, what's the square root of A raised to power 4? A raised to power 4 is a perfect square. Any number raised to power an even number is a perfect square, right? A squared times A squared will give you A raised to power 4. So the square root of A raised to power 4 is A squared over 4. And you see that we have come back to this. And that's it. So it satisfies, what should I call it now? We have the same formula. So you see that square root 3 times a squared over 4, square root 3 times a squared over 4. So using AB sine theta, using Heron's formula, it always works, and that's the beauty of mathematics, right? Better for you to know how to derive this. Is going to give you a better feel than just coming the formula. Of course, there are other cases. What if the triangle was an isosceles triangle? Well, we can just do that. I think this video is becoming too long than I expected. Okay, we'll do that and then that will be it. So look at another triangle. What? Using a highlighter for a triangle, but you just manage that, right? So for an isosceles triangle, what do we know about an isosceles triangle? We don't know what the angles are. The angles are not anything specific like that of an equilateral, but if this is theta, this has to be theta, and then we can just call this gamma. If this is A, this also has to be A, this can be B, all right? So using the formula again, that half AB sine theta, again, because we don't know the height, the area will be half, okay, we can use AB sine theta. Now we can use this. Now this is the tricky part. The formula remains half AB sine theta if I've called one of my side A, right, and called one of my side B, and the included angle. Now the most important thing is the included angle. The included angle between A and B on both sides is theta. So this would be the formula for this, right? But why do we use this when we know that A and A are the same? So we can use gamma instead. What do you think? We can use gamma instead because that will be the included angle if we are considering A and A. So the most important thing to note is what is the included angle, which sides am I using. If you're using theta, then you have to use side A and side B, but if you're using gamma, you have to use A and A because that's the included angle there. So it's going to give a little bit modification to this formula. We're going to have that the area is half A times A because B is A in this case, sine gamma. It must not be sine gamma, I'm just calling it for this my formula. So we are going to have A squared sine gamma over 2. This becomes the formula for an isosceles triangle. I just hope I got the spelling right. So let's call it a day. Thank you for joining. Please subscribe to this channel, share with your friends, and tell me what you want to learn in the comment section. Let's learn. Bye.